Okay, in this video, we're going to discuss a concept called pH. Now, pH has to do with measuring acids or bases. And the idea that we're shooting for here is we use pH and how we study acids, bases, and how they react in terms of acid rain. Now, pH is often referred to as a scale. And in general, scientists describe acids and bases along a scale of 0 to 14. So we might say something has a pH of 4 or a pH of 10.1 or something like that. Now, there are special compounds such as trifluoroacetic acid that is outside this range, but in general, in a first year chemistry course, you are not going to deal with those because those are incredibly strong acids or bases and very, very reactive. And right now, we're just trying to learn about acids and bases and the stuff that happens in everyday life. So here's a picture of the scale. You'll notice it goes 0 to 14. And usually when we use something called an indicator to measure pH, it's color-coded because different compounds react and their color may change in accordance with the pH. Now you'll notice everything from 0 to 7 is acidic and everything from 8 to 14 is basic. And another word we use for basic is alkaline. Now, when we talk about something being acidic or basic, compounds with a pH of less than 7 are considered acidic or acids. Compounds with a pH greater than 7 are considered basic, or once again, we see that word alkaline. Now, here's where it gets a little tricky. Compounds that have a pH equal to 7 are considered neutral. This means that they don't act like acids or bases in most cases. So they're not donating protons or accepting protons, as we've talked about in previous videos. However, this can also mean that protons are being accepted as fast as they're being donated by compounds. So we generally consider that anything with a pH of 7 is neutral, meaning it's neither acid nor base. And here's just another scale, another picture of the scale. You'll notice that neutral is right in the middle. And this has to do with the equilibrium values of water, which can act as an acid or a base, but that's beyond the scope of this particular video. Now, what is pH in terms, we have a number, but how do we measure it? Well, pH actually refers to the amount of H plus or protons present in the solution. So these are free protons that are moving about in the solution. They've been donated and they're looking for a base, and we can measure their concentration using molarity. Now, pH is calculated with an equation, and this is probably in first year chemistry, this is one of the weird times you'll do something other than multiplication and division. We'll use a log base 10. So pH is equal to the negative log base 10 of the concentration of hydrogen, or another word is molarity of hydrogen. Now, sometimes you'll see this written just as log. They won't include the base 10 because that's assumed. I included it here because a lot of us are in math classes with different bases, but it's always pH is calculated as log base 10, or I'm sorry, negative log base 10 of the hydrogen concentration. So, or the negative log base 10 of the molarity of H plus. Now, if the concentration of H plus is equal to 0.0003 molar, then the pH is equal to the negative log of 0.0003 molar, and that comes out to be about 4.5, which you can just use the log button on most scientific or standard calculators to calculate this. Now, one thing I do want to draw your attention to is that in terms of pH, the molarity of H plus is usually very, very low in comparison to other concentrations, simply because free protons are always looking for somewhere to attach. So there aren't a whole lot of free H plus ions in comparison to the rest of the molecule. So pH can get more complicated, and we may get into that in the future. Or if you take an honors chemistry or AP chemistry course, or definitely a college level chemistry course, you may talk about some of those exceptions. But for right now, this seems to cover all of our bases. So if you have any questions, feel free to ask, and I hope that you have a great day.